All right. You probably know this symbol. This is a symbol we use to represent a number which we call pi. So pi is a constant which describes the mathematical relationship between the circumference of the circle and the diameter of the circle. The interesting thing about pi, of course, is that we don't exactly know what the value of this number is. When we try to calculate it, we get this endless sequence of digits after the decimal point. It never settles into a repeating pattern, so it's impossible to predict what the next numbers might be as we get better at calculating this. So this satisfies the common definition of randomness. It's unpredictable and there's no discernible pattern. Similarly, this is a visualization of a phenomenon called Brownian motion. Brownian motion describes the movement of a molecule through a fluid, so through a liquid or a gas. Examples of this would be the way that dust or smoke moves through still air, or grains of pollen or water, for instance. And there's so many micro interactions happening here as the particle bounces off thousands of other molecules that the movement's impossible to predict and apparently random. So I know you probably didn't sign up for a maths and science lecture on a Friday morning. The reason I'm talking about pi and Brownian motion is that these are two tangible examples of randomness in the physical world. So if you think about how many circles you see every day, or how many liquids and gases you interact with, we normally think of our environment as being relatively stable and relatively predictable. But when we look a little bit more closely, there's this layer of chaos and uncertainty just under the surface. So that's what I'd like to speak about today, is the role that this randomness can play in the creative process. How we can take advantage of the capabilities built into our computers and use randomness to augment the creative process. And along the way, we'll look at some historical examples of artists who've explored this idea in the past. Of course, randomness already exists in some of the digital tools that we use. When we create with computers, the output is inherently precise, repetitive, and robotic. That's the nature of the tool that we're using. But we have these features which allow us to apply randomness or imperfection to make some things seem more natural and more human. Randomness is a feature of nature, and so we associate the appearance of randomness with a state of being natural, or we associate imperfection with something being human or man-made. So these features were kind of the gateway to my interest in this topic. But these represent the application of randomness as like a treatment or an effect on something that's already been created. What I'm interested in is how we can apply randomness to some more fundamental aspects of the creative process. Before I start speaking about creativity, capital C, I think it's useful to define in more specific terms what we mean by creativity. So there's a number of theories from the worlds of like cognitive science and psychology, a number of models about how creativity works, and there's two which I think are particularly relevant. The first is quite a famous one. This was proposed in the 1960s. This defines creativity as the ability to form associations or make new connections between remote, as yet unconnected ideas, and to find meaning in those new connections. Alongside this theory, this test was devised, this remote associates test, where the subject has to find a word or idea which the other three words have in common. So this was devised as a test of creative ability, but is still used today as a test of more specific cognitive abilities. The second model is something called the Genaplow model, generate and explore. This was developed later in the 1990s and describes two simultaneous processes, generative and explorative. So generating or forming new ideas and then exploring those ideas through processes of iteration and evaluation, and generating new ideas as a result of those processes. So from these two models, we can identify 4 types of process which make up what we might call creativity. So let's start with generation. This is a basic random number generator. It's essentially one line of code, as you can see, and you can run this in the JavaScript console of your browser. and it gives you a random number somewhere between 0 and 1. In this raw form, it's a little bit abstract, not really useful, but we can apply a few basic operations to this number to turn it into something more meaningful. For example, you can multiply it by 100 to get a percentage, or you can round it to the nearest integer, so 0 or 1, which gives a map that to a true or false variable, like flipping a coin. You can also multiply it by 360, as in 360 degrees of the color wheel, and then the random number is determining the hue property of this color declaration. Taking this just one step further, with two more random numbers applied to the saturation and brightness properties, this random color can come from anywhere in the entire color space. So choosing a color is a typical decision you'd make at the start when creating a piece of visual work, defining a starting point as the basis for further exploration. A similarly fundamental decision would be defining the canvas or the environment. So if I'm designing using a grid, I can use the units of the grid plus the width and height of the canvas as parameters and use random numbers to create potential layouts. So here the random numbers are simply determining where the layout guides appear on the grid. In this example, I'm using a logarithmic scale, which means each column is twice the size of the previous columns. The lines aren't coming up very well on the projector there, but I hope you can see. Here the random numbers are simply determining where the scale starts and whether it's rendered forwards or in reverse. So with just a few parameters, I can generate infinite starting points, initial conditions, or constraints. And of course, lots of these initial ideas won't be appropriate or useful, but that would also be true if they were produced by a human, probably. And that assessment, that decision, whether something is useful or meaningful, that's the second process we identified, evaluation. Luckily, I can also delegate this to a computer. If I generate a random true or false variable, like flipping a coin, the program can decide if it likes its own ideas or not. You can argue this is only slightly more arbitrary than a human. This is obviously a really basic example of a yes-no binary decision. But if you combine these decisions in a series or a sequence, if you imagine a decision tree of 4 series of yes or no decisions, the range of outcomes increases exponentially. So with 4 of these sections, you would have 16 possible outcomes. So there's, just from this basic principle, there's the potential for really complex systems, just from this basic concept. Delegating creative decisions to chance, of course, I'm not the first person to think of this. This is something called a musikalisches Würfelspiel, or a musical dice game. I thought I would include this for the typography nerds. This is something that was popular around the 18th century, where composers took advantage of the formulaic structure of certain types of music, like a waltz or a minuet. And instead of composing a whole piece, they would design the piece as a series of interchangeable parts. And then the performers can roll dice to determine in which order they're going to play the parts. And so they create a unique piece of music with each performance. Jumping over to the visual arts for a second, these ideas were explored by the Dadaists around the early 20th century. They were concerned with, among other things, removing the artist from the process of creating art, so allowing chance to determine form, composition, or even choice of materials. And back to music again, these ideas were explored famously much more deeply by composers like John Cage and his contemporaries in the mid-20th century, who experimented with delegating all possible aspects of music to chance, serendipity, and the free will of the performers. I think this is probably my favorite or maybe most useful or most fun example of incorporating chance in creative decision-making. You probably recognize this, it's quite famous. This is a set of cards devised by Brian Eno and Peter Schmidt in the 1970s. On each card is a written prompt, so a direction or a constraint, designed to encourage lateral thinking or to help overcome a creative block. So the idea is, as you're working on something, you take a card and follow that instruction as you interpret it. These are some of my favorite examples. The original cards are quite rare now, but the system's been recreated as a website and as an iPhone application, and it's all free to use. These are intended for musicians, but they're kind of applicable to any kind of creative work, or sometimes even to life in general. So yeah, this is my favorite, I think. Brian Eno, of course, the pioneer of generative music. This is actually the current version, or the current iteration of the tool that Brian Eno used in his first generative music project, if you want to try it yourself. So generative music is typically made with a computer. The composer defines a system, so a system of rules, parameters, and initial conditions. The computer then iterates on those initial conditions, often using random numbers within rules, parameters, to create continuous, ever-changing sound. So that brings us to the third type of process, iteration. Some time ago, we were toying with the idea of using waveforms in our product, similar to the way that SoundCloud does. And I needed realistic-looking waveforms in order to design the interface around them. So I made this little program which generates a sequence of numbers, where each number is a slight random modification of the previous number, and that sequence of numbers is rendered as a waveform, and the rules and parameters determine like these fades at the start and end, and the number and the sort of severity of the peaks. Of course, I could have just taken screenshots from music software or found some images online, but this way I have complete control over the appearance. This is a JavaScript program actually, so I could play with the CSS directly in the browser. Also, I just wanted to make some cool shit with random numbers. These are some well-known examples of dynamic visual identities, where the logo is not a static image, but more like a system with rules and parameters, which can adapt to, change and adapt to different contexts. So if you're working on a system like this, you can use random numbers to test a range of possibilities, to generate all kinds of variations, and use those outcomes to refine the rules. So back to my silly color program again. If I've decided on a certain color, but I want to slightly adjust it or make a texture or a pattern based on this initial color, I can apply randomness to each of the properties to produce infinite variations of this color. And of course, I'm not just creating single distinct colors here, but also relationships or associations between them. Every color forms a relationship with those around it. So that brings me nicely to the fourth process. This ability to make new connections or new associations. So here the distances are quite small, but if I widen the parameters, it creates more meaningful relationships. Of course, we have a lot of tools which will suggest complementary colors for us, or I might have my own tried and tested approaches or heuristics for this kind of process. But this way I might stumble on something that I wouldn't have found or wouldn't have considered otherwise. My last example, and probably my favorite example, this is a program which takes a list of all the fonts installed on my computer, generates two random numbers, and loads the fonts at those two locations in the list to create a random typographic pairing. Some people pay designers to do this stuff. Of course, a lot of the results are kind of weird and unusable, but occasionally it will throw up something which is unusual or interesting, something I wouldn't have tried if I was doing this manually, following the usual principles and theories. So these are the main ways in which we can use random numbers as a tool in the creative process. The examples I've shown today I know are quite basic, just intended to demonstrate the key concepts. But of course you could, Of course you can take these concepts, develop and combine them to create infinitely more complex systems. Of course, there's many important and exciting questions around this topic, particularly in the areas of artificial intelligence, machine learning, and how progress in these areas will influence generative art, adaptive interfaces, and even human creativity. There's people a lot more intelligent than me working on and writing about things like this. If you're interested in diving deeper into this stuff, I collected a list of links and articles, resources, which you can find here. It's not actually a list, but serves you a random link each time, which I figured was kind of appropriate. So I appreciate that these ideas that are a little abstract and theoretical may be a little silly and probably more suited to artistic projects than to day-to-day commercial work. But I think the lesson here is that working with randomness is one way of learning to work with and learning to build around uncertainty. So if we think like way back to the way that smartphones changed the way we design for the web, our designs that were intended for one type of screen could suddenly be rendered on a range of screens as various sizes and shapes, along with new constraints and new interaction patterns. There was this new factor of uncertainty between the thing that we've designed and the way that that thing will be rendered or experienced. Of course, we adapted to this by moving away from definitions and towards conditions, what we call responsive design. So if the screen is this size, render the page that way. If it's that size, render it another way. So as technology advances and the number and variety of interfaces increases, this uncertainty between what we've designed and the actual experience, that uncertainty will increase exponentially. So design is less about definitions and more about rules, parameters, and conditions. So the foundation of all these examples I've shown is basically just one line of code here on the right. Normally when you're learning programming, the first thing you'll do is something like this hello world example, where you tell the program to do something and the program does it. This kind of introduces you to this additive workflow where you define something and build it. And the range of possibilities is dependent on the ability of your brain to produce these definitions. Starting instead with random numbers is kind of like starting with this fire hose of possibilities. You start with everything, and in order to create something meaningful, you have to subtract and sculpt using rules, parameters, and conditions. So there's a lot more potential for weirdness. It's much easier to crash your computer, actually. But with that, there's infinite potential for uniqueness and originality. So my message today would be this. Thank you.